Let's take up more questions. Predict the products of the following reactions. This is methyl propyl ether reacts with HBr. Here we have ethoxybenzene which is reacting with HBr. Then ethoxybenzene is reacting with concentrated sulfuric acid and concentrated nitric acid. This is tertiary butyl ethyl ether reacting with HI. Let's take up one by one. 1-methoxypropane bond will break up here. Propoxide ion will take H ion to form 1-propanol. CH3 will take Br negative, will get bromomethane. Ethoxybenzene reacts with HBr. It results in the formation of phenol plus C2H5Br, bromoethane. Ethoxybenzene, when reacts with concentrated sulfuric acid and concentrated nitric acid, we will get 2-ethoxy-nitrobenzene is the minor product, 4-ethoxy-nitrobenzene is the major product, plus water will be formed. 2-ethoxy-2-methylpropane reacts with HI, the bond will break up here, tertiary butyl iodide plus ethyl alcohol, that is ethanol, is formed. 2-iodo-2-methylpropane will be the one of the products and ethanol is another product. Now why we have got here tertiary butyl iodide? Because tertiary carbocation is more stable due to inductive effect, and that tertiary carbocation will react with iodide ion to form tertiary butyl iodide or 2-iodo-2-methylpropane, and ethoxide ion will take up H ion to form ethanol. Write IUPAC name of the following compounds. Here functional group is at third position, so counting will start from this side. 1, 2, 3, 4, 5. At second carbon we have 2-methyl group, and fourth carbon we have methyl group 2,2,4 trimethyl pentane 3-ol. OH group is attached at third carbon, so we call it pentane 3-ol. Next compound, counting will start from this side. 1, 2, 3, 4, 5, 6, 7. At fifth carbon, ethyl group is attached, 5-ethyl. Total carbon atom are 7, heptane 2,4-diol. There are 2 OH groups, so we call it diol. So it is 5-ethyl heptane 2,4-diol. Here E has to be retained because next is not a vowel, it is di. That's why E is to be retained. Same way, this compound, first carbon, second, third, fourth. Total carbon atom are 4, we write butane 2,3-diol. Here also E of butane is retained because here there is no vowel. Next compound, this is trihydric alcohol, 1, 2, 3. The 3 carbon atom means propane. 1, 2, 3 triol. Propane 1, 2, 3 triol is the IUPAC name of this compound. This compound, phenolic compound, major group is OH, second carbon, methyl group is attached to methyl phenol. It is also called orthocrisol, which is common name. This compound is 4-methyl phenol. It is also called paracrisol in common system. This compound is, this OH group is the major functional group. This is 1, 2, 3, 4, 5, 6. So 2,5-dimethyl phenol is the IUPAC name. This is the major functional group. So counting will start from either of the side. 1, 2, 3, 4, 5, 6. So 2,6-dimethyl phenol is the correct IUPAC name. Here we have methoxy group as the functional group, so this will get number 1, 1, 2, 3. 1-methoxy, 2-methylpropane is the IUPAC name. This compound is ethoxybenzene. Parent is benzene, ethoxy group is attached to ethoxybenzene is the correct IUPAC name. Here this compound we have 6 carbon atom, phenyl group has 6 carbon atom, heptane has 7 carbon atoms, so phenoxy will become substituent. It is 1-phenoxyheptane. The one which has higher carbon atom will become parent. Here we have ethoxy group. It is attached to second carbon. 1, 2, 3, 4. 2-ethoxybutane is the IUPAC name. Next, draw the structure of all isomeric alcohols of the molecular formula C5H12O and give their IUPAC names. Also classify the isomers of alcohols as primary, secondary and tertiary alcohols. Now C5H12O, there are 5 carbon atoms. So we write 5 carbon atom in straight chain. 1, 2, 3, 4, 5. Pentane 1-ol is the IUPAC name. It is primary alcohol because OH is attached to the primary carbon. 1, 2, 3, 4. 2-methyl-butane 1-ol is the IUPAC name. This is also primary alcohol. 1, 2, 3, 4. 3-methyl-butane 1-ol is the IUPAC name. This is also primary alcohol. Another primary alcohol we have 1, 2, 3. 2,2-dimethyl propane 1-ol. Its common name is neopentyl alcohol. This is also primary alcohol. So there are 4 primary alcohols possible in this formula. Next we have secondary alcohols 1, 2, 3, 4, 5. Pentane 2-ol. This is secondary alcohol. 1, 2, 3, 4, 5. Pentane 3-ol. This is also secondary alcohol. Another possibility is 1, 2, 3, 4. 3-methyl-butane 2-ol is the correct IUPAC name. This is also secondary alcohol. So there are 3 secondary alcohol possible. 1, 2, 3, 4. 2-methyl-butane 2-ol. This is tertiary alcohol. So one tertiary alcohol is possible with the formula C5H11OH or C5H12O. Next question, explain why propanol has higher boiling point than that of hydrocarbon butane. It is because propanol can form intermolecular hydrogen bonding, due to which its boiling point is higher than butane. Butane, being non-polar, is associated with only van der Waals force of attraction. So alcohols have higher boiling point than corresponding alkanes due to intermolecular hydrogen bonding. Alcohols are comparatively more soluble in water than corresponding hydrocarbons. Explain this effect. Reason is alcohols are more soluble in water because they can form hydrogen bonds with water, whereas hydrocarbons are non-polar, they cannot form hydrogen bonds with water. Next question, what is meant by hydroboration-oxidation reaction? Illustrate with the help of example. When propene reacts with diborane B2H6 followed by oxidation by hydrogen peroxide in alkaline medium to form propane 1-ol, it is called hydroboration-oxidation. Propene plus diborane B2H6 gives tripropyl borane, which on oxidation with hydrogen peroxide and OH ion results in the formation of propane 1-ol and boric acid. Give the structures and IUPAC names of monohydric phenols of molecular formula C7H8O. The first one is 2-methyl-phenol, which is also called orthocresol. 3-methyl-phenol, which is called metacresol. 4-methyl-phenol, which is called paracresol. They are phenols. 2 more isomers are possible. One of them is benzyl alcohol. IUPAC name is phenylmethanol, but it is not phenol. Another isomer is possible, methoxybenzene or anisole. That is also not phenol but ether. So if you are asked write all the possible isomers, then it will be 5 isomers. 3 phenols, 1 benzyl alcohol and 1 methoxybenzene. While separating a mixture of ortho and para-nitrophenol by steam distillation, name the isomer which will be steam volatile. Give the reason. Ortho-nitrophenol is steam volatile because of weak intramolecular hydrogen bonding, whereas para-nitrophenol is associated with intermolecular hydrogen bonding. Therefore, it is not steam volatile. Next, give the equations for the preparation of phenol from cumene. Cumene is 2-phenylpropane. It reacts with oxygen on heating to give cumene hydroperoxide, which on hydrolysis gives phenol plus acetone or propanol. Bond breaks here as well as here. So here double bond is formed to get acetone and OH group gets attached to phenyl group to get phenol. So we get phenol and acetone. Acetone is also called propanol in IUPAC system. Next we have write the chemical reaction for preparation of phenol from chlorobenzene. Chlorobenzene plus NaOH at 623 Kelvin at 300 atmospheric pressure gives sodium phenoxide. On acidification, it will give you phenol. You are given benzene, concentrated sulfuric acid and NaOH Write the equations for preparation of phenol using these reagents. First step is sulfonation. Benzene reacts with concentrated sulfuric acid saturated with SO3, which results in the formation of fuming sulfuric acid. On heating, it gives benzene sulfonic acid. With sodium hydroxide, it forms sodium benzene sulfonate. When it is fused with NaOH, we get phenol plus sodium sulfite. Next, we take show how will you synthesize 1-phenyl ethanol from suitable alkenes. Cyclohexyl methanol using an alkyl halide by SN2 reaction. Pentane 1-ol using suitable alkyl halide. First, we are getting 1-phenyl ethanol from ethinyl benzene. It is also called phenyl ethene or styrene. When we treat it with water and HINs, so Markovnikov addition takes place, OH will attack here, H will attack here, you will get 1-phenyl ethanol. Cyclohexyl methyl chloride, when reacts with NaOH, NaCl is lost and we get cyclohexyl methanol plus NaCl is formed. For getting 1-pentanol, we use 1-chloropentane reacted with aqueous NaOH and we get 1-pentanol plus NaCl. Next, explain why is ortho-nitrophenol more acidic than ortho-methoxyphenol. Nitro group is electron withdrawing group, so it will increase acidic character of phenol by stabilizing nitrophenoxide ion, ortho-nitrophenoxide ion, which is stabilized by resonance. Methoxy group is electron releasing group, so it will decrease the stability of methoxyphenoxide ion by increasing negative charge. That is the reason that ortho-nitrophenol is more acidic than ortho-methoxyphenol. So ortho-nitrophenol is more acidic because nitro group being electron withdrawing will increase positive charge on oxygen, so OH bond will break easily to make it more acidic. Whereas methoxy group is electron releasing, which will decrease positive charge on oxygen, making it less acidic. Therefore, OH bond will break easily. This is another way of explaining.